this is a quick review of radicals for geometry, Dr. Geometry class. The reason that we're reviewing radicals is that we're going to be using them this week when we do our distance formula equation, our midpoint formula, as well as our slope formula. All radicals really are is another way to express fractional quantities or fractional amounts of numbers. You're probably most familiar with them in terms of a perfect square and a square root. So an example, if we have 3 and we square it, that gives us 9. So if we take the square root of that, that's equal to 3. So that radical is just another way for us to express that number 3. What we're going to do is to do some examples of simplifying radicals, because in our work this week, what will happen is our answers will come out in radical form and we'll need to simplify them. So, moving from there, let's look at our first example. So the first example is to simplify radical 294. The way that we simplify radicals is to merely factor them out, and when we have perfect squares, to pull them out under our radical sign. You'll see what I'm talking about here in a second. So 294, we probably don't have a perfect square. There aren't two exact numbers that multiply to give us 294, but we can factor it. When you look at this number, if you're like me, I can't think of a factor right off the top of my head. So if I go to my skills, I notice that 4 makes it an even number. So what I can do is I know it's divisible by 2. And so that's where I'll start with my factorization, is to factor 294 by 2. The way that looks, 2 and 147. So if I multiply, you can check on your calculator, 2 times 147, I get 294. This is the same as radical 294 can be broken down to radical 2 and radical 147. From there, what I can do is I have to obviously, I can't break down 2. It's just, 1 and 2. There's nothing there. It's a prime. It's a very small number. 147 can be broken down, obviously. And again, 1 doesn't pop out to me automatically. I know it's not even, so I'm not going to try 2. It doesn't end in 5 or 0, so I'm not going to try 5. What I will do, though, is try 3, just to see if it works. So 3 goes into 14, 4 times. Give you a remainder of 2, makes that 27. So that makes that 49. And just for bookkeeping, I'm going to bring this radical 2 down so I don't forget it. So now we have a number that actually is a perfect square. This 49 is our perfect square. You're probably familiar with that again from your multiplication class. I know 7 times 7 is 49. So I'll just express this in terms of the actual number 7. So this is now going to become 7. And I'm just going to bring down my radical 3 and my radical 2. So let's take a look. What we have is the number 7, radical 2, and radical 3. So since 7 doesn't need to be on the radical sign anymore, we can pull it out. And 2 and 3 are still underneath, so we just multiply them like normal. 2 times 3 is 6. So our simplified form of 294 is just 7 radical 6. That's it. Let's do another example. So example 2. We have radical 200. Again, not a difficult task. can't think of two numbers that multiply automatically to give me 200, so let me begin to factor it. Obviously, 2 times 100, I see that right away. So I can pull that out. And radical 100. So what I see automatically right there, perfect square. 10 times 10 gives me 100, so I'm just going to make this into 10. Pull my radical down just for bookkeeping purposes, so I don't forget it. And I can now express radical 200 in a simplified form as 10 radical 2. A few more examples. Let's look at radical 48. So take a few seconds. If you're watching the video, maybe pause it, see what you get, then check, then start it back up and check and see if your work corresponds to what I'm doing. So 48, I know, let's say 6 times 8. I know that for a fact. Neither one of them are perfect squares though, so square root of 6, square root of 8. 6 will break down for me into 2 and 3, so square root of 2, square root of 3, and 8 will break down for me into 2 times 4, so square root of 2 times square root of 4. So one thing I noticed when I work the square root of 4 is that it is a perfect square, so this can just become a 2. Now let's take a look. I have 2 numbers that are under a radical sign that are the same. What that means is, as a pair, I can pull these 2 out, and that can just become a regular old 2 now. And so my factorization can look like the following. I can have my 2 that I pulled out with my 2 radicals, and for bookkeeping, I'm going to bring that radical 3 along the way, and I also have another 2. So like we saw before, when they're out underneath the radical sign, they're going to go in front of the radical sign. So it's just 2 times 2, radical 3, and of course 2 times 2 is just 4, so 4 radical 3. So the way that we can express or simplify this radical square root of 48 can be expressed as 4 square root of 3. Since I know you guys love fractions, let's do an example of fractions. 4 radical 16 over 81. So rather than look at this as one fraction, we can actually break this apart into a radical in the numerator and a radical in the denominator. So we'll have radical 16 over radical 81. And as luck would have it, square root of 16. Radical 16 is a perfect square. So this is going to be 4 on the top and 9 on the bottom. 4 times 4 is 16, 9 times 9 is 81. So that reduces down or simplifies down to 4 9s. One last example. Square root of 24. So we have something out there in front of us automatically. We're just going to carry it down. Again, we're going to do the bookkeeping piece, and we're just going to carry it with us the whole way through until we finish what we have to do with this radical. So let's go ahead and take care of the radical. So it's just going to come down. And 24, the first one that comes to my head is 6. 6 times 4 is 24. Know that 4 is a perfect square. So I just, the square root of 4 is a perfect square, so that just becomes 2. And let me see if I can do anything with the square root of 6. Down to radical 2, down to radical 3. So what I notice is, again, it looks a little bit like our previous example where we had 2 numbers. What you'll notice different though is that this right here is under the radical sign, while this is not. So the way it worked last time, they both have to be under the radical sign in order for us to pull them out. Since one of them is already out, it just has to stay out, and this one has to stay inside. This one needs to stay inside right here. So what we end up getting we have our 7, which has been out there for a while. We're going to take our 2, bring it out. And underneath, we'll just take it back to a radical 6, since we couldn't do anything with them. And we end up with 14 square root of 6. So what we've seen is that we can simplify the radical 7 square root of 24 into 14 radical 6. It doesn't seem simpler unless we understand that this 24 is radical 24. It's actually an expression for a much larger number. Alright, that is the review. Make sure to click on the other videos on distance formula, midpoint, and slope.